Hello! In this video, we will be talking about forces, one of the most important concepts in understanding not only Newton's laws, but motion in general. So first, what is a force? So when we talk about a force of any type, we mean a push or a pull on an object resulting from an interaction with another object. We experience and apply and feel forces all around us all the time. Let's look at some examples. So a simple example of a force being applied is hitting a baseball with a bat. When that baseball comes into contact with that bat, swing it backward, and you swing the bat around, that bat is applying a force onto the baseball. Another example of a force that we all experience all the time is that force that's pulling us down onto the floor. When you jump up, you're inevitably going to come back down. When an apple falls off of a tree, it's not going to float in the air, it's going to fall down to the ground. That force is gravity. That apple that's being pulled down from the tree onto the ground is experiencing a pull by gravity. Now, we're going to talk about the two different classifications of forces and all of the different forces that there are, which fall into one of two categories. So the first category of forces is called contact forces. So when we think about the word contact, what do we mean? We mean being in contact or physically touching. So you can already probably take a second to think what those kind of forces might mean. So when we say a contact force, we mean forces which require physical contact or physical touching in order to be applied. These are the forces that we probably apply and experience all the time on a day-to-day basis. Now let's look at the different types of contact forces that we will be investigating. The first is called an applied force. Next, we have frictional force, or it could just be called friction. Another contact force is air resistance. Finally, we have the normal. Finally, we have tension. This can also be called tensile force. And those are my 5 types of contact forces or forces which require physical touching in order for the force to be applied. The next type of force or category of force is non-contact or at a distance forces. The very opposite of a contact force, you can probably already piece this together. Non-contact or at a distance forces are forces which can be applied from far distances, meaning the two objects that are interacting, applying, and experiencing the force do not have to be in physical contact in order for those forces to be applied. The first type of at a distance or non-contact force is gravity. Then we also have magnetic force. And finally, electric force. Now that we know the types of forces, let's talk in a little bit more detail about each kind of force that we have. We'll start by talking with an applied force. So an applied force is any force that is simply directly applied to an object by another object. So these are those forces that if I say apply a force to something, you would probably easily know just to push or pull on it. That's an applied force. So some examples here are pushing a box across the room, pulling a door open, a car crashing into another car, the baseball bat hitting the baseball is another example. If you pushed your friend, you would never do that, but if you did, if I push the keyboard down in order to push a button, I am directly applying a force onto another object. That is a applied force. Next, we have frictional force. You've probably heard of friction before, so maybe if you think of friction, you think maybe going like this, and your hands start to get warm, you might think about sandpaper rubbing on something, so you probably already have an idea of what friction is. When we say frictional force, this is the contact force which occurs between two surfaces as they slide against each other. So in all of those examples that we just said, we see that there are two surfaces, so two different surfaces of objects that are sliding against each other. This is when friction occurs. Friction, because the two objects are sliding against each other, it often works in the direction opposite of motion. I'll explain that when we look at our example. So we talk about sandpaper sliding on wood. The whole reason why we use sandpaper on wood is because of the friction that it produces, which allows it to sand or to smooth out that wood. Brakes slowing down a car. Here's where we can talk about working in the opposite direction of motion. So if you think about brakes, when you hit the brake pedal, pushing that thing on the floorboard is not what actually slows the car down. There is a brake pad that squeezes onto the actual tire or the rotor, which then applies friction or causes friction, which eventually slows down the wheel from spinning and stops the car. The reason that it slows it down is because friction is working in the opposite direction of the motion. The car wants to go this way, the wheel wants to spin this way. Friction is working in the opposite direction, hence slowing it down from spinning and eventually stopping the car. Pulling an object across a surface, you can also think about that working in the opposite direction of motion. Imagine if I asked you, would it be easier to pull a very, very heavy box across a floor that had nothing but gravel and rocks on it, or across smooth ice or smooth tile? Of course, it would be easier to pull the box across the tile or the ice because there's less friction between the surface of the box and the surface of the floor, working against your motion. The next type of applied force that we'll talk about is air resistance. So air resistance is actually a form of friction which occurs as an object travels through the air. So you've probably heard of air resistance in a few different examples. So one that I like to use is as you drive down the highway in the car. Have you ever stuck your hand or your palm out of the window of the car? What happens to your hand? Well, it's blown back and you feel quite a bit of force depending on how fast the car is going on the palm of your hand. That is air resistance, which is air actually pushing back against the surface as it tries to travel through air. You can also see that if I were to try to push my hand when there was strong air resistance, it would be harder to move my hand. That's because that friction or that air resistance is working opposite to motion. Skydiving is another example where we see air resistance. If there were no air resistance, skydiving would not be a thing because it wouldn't work. So air resistance, once the skydiver jumps out, he falls for a while. He's experiencing a lot of air resistance as he's falling, and then his parachute deploys, which using air resistance slows him down enough to make a safe landing. So those are a couple of examples where we see air resistance playing out in the real world. Next, we have our normal force. So normal force, very important and very easily forgotten. So don't forget about our friend normal force. So normal force is the contact force which is exerted or applied upward onto an object by any surface that it is resting on. So this could be a book sitting on a table. This could be me sitting in this chair, my computer sitting on top of this table. Anytime an object is sitting or resting on a surface, there is a normal force being applied upward onto the object by the surface. Very important, normal force always, regardless of the angle of the surface, acts perpendicular or at a 90-degree or right angle to the surface. Let's look at what we mean. So if we talk about sitting on a chair or standing on a ground or a book sitting on a table, the normal force again is that blue arrow force being applied back upward onto the object by the surface. So this is a force that the table is applying back up onto the book, or that the chair is applying back up onto your body, or that the floor is applying back up onto your feet. Now, we can see here that in this example, the normal force is perpendicular or at a right angle to the surface. You can see here very clearly. It's important to notice that if that surface is an angle, like a hill or a ramp, the normal force is still perpendicular to the surface. So in this case, the normal force would not be straight up. It would be again at a 90-degree angle to this surface, this incline, which looks like the line we see here. Finally, for contact force, tension or tensile force is a force applied by a rope, a string, a cable, a wire, or other long, linear, thin, or similar object when it is being stretched. So any object like a rope or a string or a wire or a rubber band or anything rope or string like experiences or applies a force called tension. For example, anytime a rope is being pulled or pulling an object, there is tension in that rope. That rope is applying tension to the object that it is pulling. When I stretch a rubber band, there is tension within that band pulling on whichever objects are stretching it. There's tension within the length of the band. Anytime an object is hanging from a string or a wire or any similar object. Now we'll talk about our at a distance or non-contact forces. The first and most important non-contact force for our unit is gravity. So we've all heard of gravity, I'm sure. So gravity, which we can also call gravitational force, is the universal force of attraction between all objects. So let's take a minute to break this down. So you've heard of gravity. You know that when you jump up, you're eventually going to fall back to the ground pretty quickly. And you probably know that that is because gravity is pulling you down. What you may not know about gravity is two things. First, that gravity is universal. So you've probably heard that in space there's zero gravity. Well, zero gravity is a little bit of a misnomer or an incorrect statement. So gravity, though it can change in its strength based on different locations, is universal, meaning that anywhere in the universe, there is gravity. The second piece that you may not know about gravity is that it is the force of attraction between all objects, not just between things and the Earth. So all objects in the universe actually have a gravitational pull. We'll talk later in our gravity lesson about why the Earth's gravitational pull is so much stronger, but all objects are constantly attracting all other objects around them through the force of gravity. But in the real world, what we see gravity doing is acting as the force which pulls objects toward the surface of the Earth. So the reason why the apple falls from the tree, the reason why eventually a plane is going to come back down. If you throw a ball, it will fly for a little while, but then it will fall back to the ground. That's gravity. We also may know that gravity is the force that keeps all of our planets and celestial bodies within our universe orbiting around the sun. So that helps you to notice that, can't say there's zero gravity in space, and we also can't say that it's just the Earth that has a gravitational pull. The next type of at a distance force is magnetic force. So again, we've all heard of a magnet before. So what is magnetic force? Also known as magnetism, magnetic force is the force that is exerted between magnets and magnetic objects. This could be a magnet sticking to a refrigerator, the magnet being the magnet and the refrigerator being a magnetic object. A maglev train, which is a very, very high speed that actually uses super-powered magnets to allow it to levitate off the tracks. Or one of those large magnets picking up junk at a junkyard, like the one you see there. Or something as simple as a magnet attracting iron filings, as we see here. Our third and final type of at a distance force is electrical force. Electrical force is the attractive or repulsive force between two charged objects. So objects can be charged, either positive or negative, based on the number of subatomic particles that it has. Electrical force can either be attractive or repulsive. If they're two like charges, meaning the same, so two positive charges or two negative charges, those charges will repel or push away. Unlike or different charges, like positive and negative, or neutral and a charged object will attract or be pulled together. You may have seen an example of this. Very simply, if you rub a balloon onto your hair or onto a sweater and then hold it up to your hair or a piece of tissue or a piece of plastic, it will actually attract or pull that towards it. A very simple example of electrical force, one of our three at a distance or non-contact forces.